Hello and welcome students. My name is Shampa. In today's class, let us understand the concept of highest common factor of two or more than two numbers. So let's begin. Now we are familiar with the term factors and multiples. If you are not familiar, in case you have any doubts, please refer to my last video about factors and multiples. So we know what are factors, we know what are multiples. Just a quick recap. When we multiply two numbers, we get a product. And the numbers we multiply together to get the product are the factors, and the product that we obtain is the multiple. Now, if we have two numbers, say we have 24 and we have 36, and we want to find out if there is a common factor between two numbers. Well, there are many. If we prime factorize 24, we will first divide it by 2, we will get 12. Now let's divide it by 2 again, we will get 6. So the factors of 24 are 2 into 2 into 2 into 3. And the factors of 36, likewise, we can find out the factors of 36, which is 2 into 2 into 3 into 3. So we have factors which are common between 24 and 36. 2 is common, 3 is common, and we have 4. Here we have 2 into 2 and here we have 2 into 2. So 4 is also common. So there are many common factors between two numbers. But what if we want a highest factor? What is the highest factor that is common between 24 and 36? Let's find out. Here we can see we have 2 as the common factor. Let us round it and let us consider it, and we will take out 1 2 out of these two, and we have another 2. Take out 1 2 out of these two, we have this pair of 3. That's it. We have 2, so we group 2 2's together, and here also we group 2 2's together, and here we grouped 2 3's together. So we took out 1 out of these two, we took out 1 out of these two, and we took out 1 out of these 3, and we have got the result as 12. So 12 is the highest factor, highest common factor between 24 and 36. Now the question is, where are we going to use the concept of HCF, or the highest common factor? By the way, let me tell you, highest common factor is also called GCD. GCD, which stands for greatest common divisor. Now let us understand, where do we use this concept. Say we have a rational number, say 72 by 84. Now we know the definition of rational numbers, we know what are standard form of rational number. Now if we want to convert this rational number to its standard form, what are we going to do? These two numbers have a factor which is common, and because of the existence of that highest common factor, this number is not in its standard form. So if we cancel the highest common factor from the numerator and the denominator, we will get the standard form. So let's do it. 72 can be broken down into 2 into 2 into 2 into 3 into 3. You can verify it by the prime factorization method, and 84 can be broken down into 2 into 2 into 3 into 7. So at this stage, what we will do is we will take the we can cancel out the common factors, and finally we are left behind with 6 by 7. So 6 by 7 is the standard form of 72 by 84. Well, normally we don't do it like this. We have 72 by 84. What we do is, normally we write down the HCF separately and the number which is not common separately. We can write 72 as 12 into 6 and 84 as 12 into 7. So 12 and 12 will cancel out each other, and we will be left behind with 6 by 7. You know what? In due course of time, you will get used to it. If you see a number, if you have to be good with tables. If you see a number like, if I say 91 by 104. In this case, 91 is a multiple of 13, so is 104. So you can write it like this. 13 into 7, 13 into 8. So here 13 is the highest common factor. So there is a 13 in the numerator and there is a 13 in the denominator. They will cancel out each other, and the standard form is 7 by 8. This is the standard form of 91 by 104. Now let us understand the concept of LCM of two or more numbers. It is used in the concept of rational numbers. How? We will see that. But let's go ahead with LCM, with the concept of LCM. So LCM stands for least common multiple. Least common multiple of two or more numbers. Say we have two numbers. Let's take the example of 24 and 36 again. Normally I prefer to take the same examples. That helps to understand the concept better. Now we found out the HCF. Let's prime factorize it again. And let's prime factorize this as well. So here we have the factors of 24, which is 2 into 2 into 2 into 3. If you are a beginner, please prefer to write the factors at a sufficient distance so it's easy for you to understand. And the factors of 36 are 2 into 2 into 3 into 3. Now we know how to find out the HCF. We are not in a quest to find out the HCF, but using the HCF, we will go ahead and find out the LCM. Let's see how. 2 is common, so we will take out 1, 2. Here also 2 is common, we will take out 1, 2. And here 3 is common, so we will take out 1, 3. So the HCF is 12. This is step 1, find out the HCF. And after we are done with step 1, let's move on to step 2. Amongst the factors of 24 and 36, find the least prime number and find the highest power of the least prime number. Well, the least prime number in this case amongst the factors of these two, the least prime number that has not been taken as common is 2. And the highest power of 2 is 1. We don't have another 2. So the highest power of 2 is 1. So use this 2. And then take the next least, take the next prime number. Here we have 3. And the highest power of 3 is again 1. So we will use that too. So in this case, we have the LCM as 12 into 2 into 3, which is 12 into 6, 72. So 72 is the least common multiple between 24 and 36. You can verify it. 24 into 3 is equal to 72. 36 into 2 is equal to 72. So 24 has numerous multiples. 36 has numerous multiples. There are many multiples of 24, like 24, 48, 72, 96, 120. 36 has numerous multiples. 36, 72. 108, 144, 180, and so on. But we can see from these numbers that amongst all the multiples, 72 is the least common multiple. If we still go on, after 120 we will have 144. So the next multiple of 24 and 36 is going to be 144. I'm sorry, this is not 140, this is 144. I'm extremely sorry about that. So after 72 we have 144, which is common between 24 and 36, but the least is 72. So 72 is the LCM. That was one method to find the LCM. Let's try one more method. This time, let's take a different number. Let's say 102 and let's say 119. Let's take the LCM of these two numbers. I hope most of you have guessed it right. HCF is going to be 17, but we are in a process to find the LCM, so let's do it. First, we will take the least prime number, which is divisible by either of these two numbers. So 2 is the least prime number. We will divide 102 by 2, but 2 does not divide 119, so leave it like that. So if you divide 102 by 2, we will have 51 and 119 will be left untouched. So 2 doesn't divide 51 and 2 doesn't divide 119, but 51 is divisible by 3. However, 119 is not divisible by 3. Never mind. Let's go on. Divide 51 by 3, we will have 17 and 119. In this case, let's see if 119 has if there is any other prime number that divides 119. Well, 5 can't divide 119, nor can it divide 17, but 7 will. 7 will not be able to divide 17, so it will remain as it is. But if we divide 119 by 7, we will get 17. Remember, 17 into 7 is 119. Now we are left with these two prime numbers and we can't divide it with any other number. That's why they are called prime numbers. Divided by 17 and we will get 1 and 1. That's it. We won't proceed further. The moment we get this, the moment the numbers are reduced to all their prime factors, we don't have anything else to do. We will just multiply them all. So we have 17 into 7 into 3 into 2. This is going to be the LCM. So we have 17 into 7, 119 into 3 into 2. So we have 119 into 6. Let's multiply. 9 6 are 54. Here we have 714. 714 is the least common multiple of 102 and 119. So in today's session, we understood the concept of highest common factor and least common multiple and how to find them and where to use them. But we have not yet understood the application of LCM. So let's see where can we use it. Let's see. Let's say we have two rational numbers and they have a different denominator. They have a different denominator. How are we going to add them? Simple. Take the LCM. I know we did it in one of the sessions, but let's quickly revise it. LCM is going to be 91. Now, write down the rational number and multiply the denominator to a number so that we get 91 and multiply the numerator to the same number. So in this case, we have got 98 by 91 and let's treat 17 by 7 the same way. We will multiply the numerator and denominator by 13. So the denominator will become 91 and the numerator will become 221. Now we have same basis, that is the same denominators. What we are left behind is we will just add the numerators. So the numerator is 98 plus 221. It is 319 by 91. So this is the rational number we have achieved by adding two rational numbers with different denominators. Also, we use the concept of LCM to compare two rational numbers. Let's see. Let's take a simple example this time. Let's say we have 2 by 7 and 3 by 5. Now we are going to compare these two rational numbers. We also know a method that if we cross multiply, we will be able to compare two rational numbers, but this time we are going to use the LCM method. We have 2 by 7 and 3 by 5 and the denominators are 7 and 5. So the LCM is going to be 35. You know something? The denominators 7 and 5 are actually coprime numbers. Coprime numbers are numbers that do not have a common factor between them other than 1. Just remember one thing, that coprime numbers need not necessarily be prime numbers. They can be composite numbers, but The point is, they do not have a common factor other than 1. Like if I take the example of 7 and 9, 9 we know is not a prime number. However, 7 and 9 do not have a common factor between them other than 1. That's why they are called coprime numbers. Now let's get back to our question. Here 7 and 5 are two coprime numbers. Whenever we are supposed to find the LCM of two coprime numbers, in that case, simply multiply those two numbers. You don't have to put much effort into it. Just multiply those two numbers. So, let's revise. Whenever there are two coprime numbers and we are supposed to find the LCM of two coprime numbers, just multiply the numbers and the result is going to be the LCM. So here 7 and 5 are coprime numbers. So the LCM is 35. We have 2 by 7 here. Let's make the denominator 35. So multiply it with 5 and multiply the numerator with 5. We have got 10 by 35. Now we have 3 by 5 here. We will multiply the numerator and the denominator by 7. We will get 21 by 35. Clearly we can see 21 by 35 is greater than 10 by 35. Therefore, we can say 3 by 5 is greater than 2 by 7. So this is how we use the concept of LCM to compare two rational numbers. So in today's session, we learned about the HCF and LCM, how to find them and where to use them. See you in my next session. Till then, please take care of yourself and have a good day.